All right, so here are the 3.5 solutions. Again, I used the method that I thought was best for each individual problem. If you used a separate method and you have questions about your approach, please feel free to ask in class. So number 10, since nothing was just plain old x or plain old y, I used elimination. I started by multiplying my first equation by -2 to get rid of my y values, my other equation by 3 to get rid of my y value again, and so I was able to get opposite signs for my y values. They add up to 0. -16 and 9x get me -7x. Notice I've got this 15 that I have to move later. -6 and 0 get me -6. So I subtracted 15 from both sides, divided by -7, got my x value. And then I went back and used the first equation, substituted 3 in for x, and then solved for my y value. And again, don't forget to give your answers as ordered pairs. So 11, again, since nothing was plain old u, plain old v, I decided to use elimination again. Again, remember, ordered pairs are written in alphabetical order, so my answers are going to go -u, v. I decided to get rid of the u value, since then I would only have to multiply one equation. And so to change 2 into -6, I multiplied by -3. Distributed through my problem, got -6u minus 9v equals -18. Those add up to 0. 5 minus 9 is -4. -2 minus 18 is -20. Divide by -4 and get my v value. For this one, I went back to my first equation to substitute in for v, solved for my u value, multiplied my 5's together, subtracted 25, divided by 6. And then again, don't forget to give your answer as an ordered pair, in this case, u, v. Since I hadn't done substitution yet, I decided to do number 12 by substitution. Again, you don't have to, but I figured I would show the steps. So I used equation 2 to isolate q, added 6, added q. So I have my value for q. Now, since I used that second equation, I have to use the first equation to substitute in. Substitute in my q value, distributed 2, and now I start combining like terms. 3p plus 18p is 21. I subtracted 12. Divide by 21, I get my p value. And then I could have used this equation to make my life easier, but I went ahead and substituted into the original number 1 to solve for q. And again, don't forget to give your answers as ordered pairs. Now, the rest of these problems are like that situation that I was telling you about where they, for some reason, jumble up the order. So the first equation, I subtracted 4y to get this into ax plus by equals c form, subtracted 9x to get in my second equation into ax plus by equals c form, and then I decided that I was going to cancel my y's since they already had opposite signs. So a common multiple of 4 and 6 is 12. You could have used 24. I used 12. So I multiplied my first equation by 3, my second equation, my second equation by 2. I distribute to all my terms. And then inadvertently, x's cancel, y's cancel, and I get a false statement. Now remember, if you get a false statement while solving an equation, the answer is always no solution. 21 looked like it was a good opportunity to use some substitution, but I didn't want to have to deal with this fraction 3/2, so I decided to eliminate my p-values by multiplying by -2. Conveniently, when I did that, -2 times 3/2 got me -3 since the 2's canceled. So in an attempt to avoid that fraction, I actually got rid of it. My 2 p's add up to 0. I get -8q equals 4. Divide by -8, and q is -1/2. Again, I wanted to avoid this fraction, so I subbed q into that first equation and started solving. -5 times -1/2 is +5/2. I subtract 5/2 from both sides. Divide by 2. Remember, when you're dividing by 2, it's the same as multiplying by 1/2, And so that gets me my 23/4, and I've got my solution. Remember, ordered pairs are written in alphabetical order, so this final answer is going to be C, comma D. They really have set this one up perfectly for me to use substitution, so that's what I did. I took equation 2 and substituted in equation 1. Conveniently, when I distributed that 1/2, 2 times 1/2 is 1, -6 times 1/2 is -3, I was able to eliminate any of my my fractions. Combine my two like terms, subtract 1, divide by -4. Remember, 0 in the numerator is okay, so 0 divided by -4 is 0. And then I took that first equation, substituted in what C was, found that D was 2, and then again, don't forget to give your answer as an ordered pair. 23 again was one of those ones that's not quite in the form I'm used to, but I noticed that on my left side, I had x's and y's. On my right side, I had x's and constants. So I just went ahead and combined my two equations. When I combined them, the y's canceled out, and I got 2x equals 2x. For some people, that's enough to go right to the answer. It's a true statement. Others might not notice until they get 0 equals 0 that they have a true statement. And then again, remember, for any time we get a true statement, our answer is infinite. But in these cases, it's only infinite to these lines. So all xy on the line x plus y equals 3x minus 1. Or, if I had wanted, I could have used the other equation. It doesn't really matter which of the two equations you pick. 24 seemed a little bit more complicated, so I rewrote them into ax plus by form. I decided to get rid of my y values, so I just multiplied my second equation by -1. Y's add up to 0. 3x minus x gets me 2. 2 minus 2 is 0. Again, 0 in the numerator is okay. I took my first equation from up here, my first equation, substituted in my x value, got that y equals 2, and again, don't forget your answer is ordered pairs. And so then finally, these ones seem pretty complicated, so I took the time to get them into ax plus by equals c form. I noticed that the x's already had opposite coefficients, so I went ahead and combined those two lines. I got 6y equals -2, divide by 6, and y is -3. I took this second equation, substituted in what y was, added 1/3 to both sides, got my x value as -2/3, and gave my final answer. Again, you could have used other methods, and that's fine. If you have questions about your other methods, they should always lead to the exact same correct answer. So if they didn't, you made a mistake somewhere along the way. If you want to talk about it in class, please don't hesitate to ask.